So, hello, good afternoon. Welcome from Austria. Welcome to this Fronius webinar today. The topic is the backup power with Fronius Symo Hybrid and Gen 24 Plus. We are here today, two persons. It's me, Hans Pelzer. I'm doing a presentation for these next 40 minutes. And beside me is Christoph Schierlinger, who is in the chat room waiting for your questions, and he will try to answer that immediately. So feel free to send us your questions in the question range area, and we'll try to answer that immediately. Good. What's the agenda? I'd like to explain you first of all something about some general information about backup power and the Fronius Symo Hybrid inverters, as well as the operation. How does it work? And then the installation and commissioning, the commissioning process with our inverters. And finally, I would like to give you also a short outlook about the new product, the Fronius Gen 24 Plus inverters, and how does it work with those inverters. Good. Some general information. I'd like to start with basic definition of the hybrid inverter. So the hybrid inverter is not an off-grid inverter. We use our system is made for houses with grid connection, but maybe a region with an uncertain power supply, power cuts, and a high density of PV systems, for example. So in this case, we use a hybrid inverter. So that the hybrid inverter should just cover the power cuts to give the customer power supply even in a short power cut. Therefore, at the moment, I would like also to ask you a question before I start. And the question is actually, how important do you see the backup power function in your market? Sorry for this. The first word is how. How important do you see the backup power function? Is it not important at the moment? Maybe in the future, is it important for only a few customers ask for that? Do you have a high demand from your customers, but you don't know the real easy solution, so you're a little worrying about that? And last, is it very important and it's a kind of standard for you? You just do that for most of your installations. Good. Already 70% have voted. Thank you. I think 75%. That's great. Thank you very much. I will close that now and show you the result. Basically, most of the people see it very important, and it's a kind of standard already, so that's great. 29% said a few customers asking for that, so it's for some customers a solution. High demand also for 21%. So maybe I can show you here our solution, an easier solution for this one. And just a few said it's not important, maybe in the future. Good. Thank you for your feedback. Then I'll continue with the first basic explanation about our system. Our system is a so-called DC coupled system. Basically, we have the inverter, the hybrid inverter, Fronius Symo Hybrid, 3-phase inverter, the PV generator, a battery, and then you supply your loads, and then after that we have the backup power switch. So when the grid is when there's a blackout, let's say, this switch needs to switch over and of course isolate the system from grid. And then last component which additionally is required, this is the Fronius smart meter. So this is just after the energy meter, another the meter to give us feedback about the feed-in point, more or less. So we need to know what's going on at this point, because all surplus energy will be charged in the battery, and therefore we need this smart meter at this position. Yeah. Basically, this is the basic principle system for a new installation. When you have an existing system, you can also use the application AC coupled. Here you see there's an existing inverter with a PV generator, and you have as well here, you add here the AC coupled system of a battery. So in this case, the power flow will go through the second inverter. So basically from this existing inverter, it goes to AC, and then via the Symo Hybrid to DC again, and then to the battery. So also this would be a possibility, typical AC coupled battery system. With our system, we have also the advantage that we can also add on a PV generator on the Symo Hybrid here as well. And with that, you have the possibility to recharge the battery even in a blackout situation. So whenever you have a longer blackout, few days, the battery will be recharged from the PV generator as well in this case. If I would have no PV generator on the Symo Hybrid, I would have no chance to charge from PV the battery, because the backup switch is switched off. There's no power flow from the existing inverter to the battery anymore, and then of course you can use your battery capacity only as long as it's as you have as some kind of charging in the battery. So that's the basic idea behind our system. And what common components are required? Basically, the Fronius Symo Hybrid inverter with the Fronius solar battery or BYD battery box HV. This is the existing solution. So whenever you have already existing solution, then you need to use this solution. For all new solutions, as of Q3 2020, we can offer as well a new inverter with the Symo Gen 24, and this comes also with the new BYD Premium HVS or HVM version. So we need here the high voltage version because it's a DC coupled system, and here you can use this new battery with the new Symo Gen 24 inverter. But you can also use, of course, the existing Symo Hybrid inverter, which is in a power class up to 5 kilowatt, and the Symo Gen is then for higher power classes from 6 to 10 kilowatt. And additionally, of course, we need the backup power components, so the conductors and relays, what are required to switch over to backup power mode. And these components are as followed. Here, the Fronius smart meter, the 6 amp fuse, a 12 volt DC relay, this kind of Finder relay with one normally closed contact and one normally open contact, and as well 2 main contactors, 230 volt AC, 3-pole or 4-pole with one contact normally closed. You see here, you just need to take care about the current, but this is made usual standard in Europe to use 2 conductors. Yes, or the other solution is with the EnviTech box. On the EnviTech box, we have different solutions as well. If you go to www.envitech.eu, you will find these configuration scheme on their web page. So you can choose, you select the inverter, first Fronius inverter, and then you select the 3-pole or 4-pole contactors, and then you select if there is an additional ENS required or not, which is in some countries required, but very few. And then you can more or less order this box from your distributor or from Envidec direct. Yeah, so of course this is the easier solution because everything is pre-configured and pre-wired. So you just need to take 4 cables out of the switch box and after the energy meter, and then go back. So that's basically a simple installation here. On the other hand, of course, the cost of this solution is maybe a bit more expensive. Yeah, what's important for the realization, or what additional information is important? First, you need to order these additional components. Then take care there are different circuit diagrams or different requirements from your grid operator. We have some diagrams available on our webpage. I can show you later on the link where you can find this. Of course, this can be different, a little bit different in your country. So take care, get first in contact with your grid operator, what they require, and then order the components and do the wiring accordingly. There is a switch over time for about 60 seconds. That's important as well. So when we switch over from grid to off-grid mode, there is a 60-second break. So that's something to be known as well. And we have a maximum of 15% running time in emergency power mode per year. So we can double check this. What we want to make sure with that is that you use this system not in an off-grid system, but only in a grid connected system, because the semiconductors, the power module is of course is in a higher temperature when we run in off-grid mode. So we will probably have some issues with the long warranty terms of 7 years, that there could be a little bit more problems when you run on pure off-grid mode. So therefore we said it's not made for off-grid mode, it's made for an on-grid mode, on-grid situation, but with some power cuts. Yes, then we have different applications, so take also care about maybe a split up of the loads in a house. It can be an advantage if you split up the loads, because of course some very high power loads, for example EV charging station or maybe a heat pump with a high power, can of course discharge the battery in a few maybe an hour or so, and then of course the customer has no more energy for the other important loads in the house, which is maybe a refrigerator or some lights or whatever. So therefore take care, ask the customer what loads he has got in his house. Is there anything which is maybe not needed in a power in a blackout situation, and then it would be good to split up the loads. Yes, this is actually the basic points. Then what about the continuous power in backup power mode? On the Symo Hybrid 5 we can offer 5.1 kilowatt. With the Symo Gen 2410 we can offer 10 kilowatt. Maximum here is 12 kilowatt, but for maximum 5 seconds. Then power per phase, maximum 2 a bit more than 2 kilowatt on the Symo Hybrid 5 and 3.68 kilowatt on the Symo Gen 24. So we have here, of course, higher power per phase as well. And the discharging current is also different, 16 amps for the Symo Hybrid and 22 amps for the Symo Gen 24 10 kilowatt. The maximum discharging power depends also on the connected battery. So therefore you need to multiply the battery voltage with the amperage. For an example, a solar battery with 7.5 has got a battery voltage of 250 volts. Multiplied with 16 amps gives a 4 kilowatt nominal output power from discharging in backup power mode. So basically, you can also say that the battery modules have usually about 50 volts, also with BYD. When you use a bigger battery with 8 modules, you have a voltage of about 400 volts. So that's also important to be known, because with that, of course, you have a higher discharging power as well, and you can, of course, get more energy whenever you use the system in backup power mode. Good. Then let's see at for how this works. Sorry, one back. The backup diagram looks like this. So when you after the energy meter, we have the Fronius smart meter again, and then these two conductors, these two switches to switch over from the grid mode to the backup power mode. These two conductors are supplied here from phase 1, means and neutral. So whenever we have power from the grid, these two conductors are switching on. Then the K3 is the small relay which we need to switch over as well, and therefore we are we disconnect here or we switch off the K2 and K1 as well with this relay. The pins on the hybrid inverter can be found just if you look in the inverter behind the datcom cover, there is this orange plug. It's an 18-pole plug, and here you see also the pins, and you need to use pin plus I4, I5, and IO0 to connect the additional relay and feedback from the contacts of the relays. So that's important. I'll show you a bit better in the next slide how it's working. Basically in the feed-in mode, so normal grid supply, we see K1 and K2 are closed because they get power supply. They are supplied via L1, F1 and K3. Here these two conductors are supplied and they switching here on, and so you get the grid power to our loads and to the Fronius Symo Hybrid inverter. Then as soon as we in this moment the inverter will run and there's no feedback on I4 and I5, so they're all off. That means for inverter, okay, this is feed-in mode. In the backup power mode, we first detect here there's no voltage. K1 and K2 will immediately switch off. So there's no supply here. L1 is there's no power. The two conductors here switching off. So they insulate here the AC side from the loads and the hybrid inverter. After that, after a while, IO0 will send a signal to the relay, to the 12-volt relay, and the relay will switch off here to make sure that these conductors are not immediately switching on again. Yeah? So this is a kind of safety here. We switch off here these conductors. And then we also get a feedback. We get a feedback, first of all, that K1 and K2 is open, and also that K3 has switched on. So here we know that this more or less is in off-grid mode. And we get also the feedback, I4 and I5, we get this 12-volt signal from the plus pole back to I4 and I5. As soon as the backup power mode is working, the system runs in 53 Hertz off-grid mode. Okay, so that's the operation, and now the 4 steps for the installation and commissioning. That's basically first the smart meter. You see we have the Fronius Symo Hybrid inverter with this orange plug, this 16-pole plug. On the right hand side is my switchboard, where I have or the NVDEC box, well similar, where we have the smart meter, the Fronius smart meter, connected on the pins D+, D-, and ground, and then K1, K2, and the relay K3. Basically, we need 12 volts here on the feedback loop of the conductors K1 and K2. They're going back to I4. Yeah? So we know here the information of the status of K1 and K2. And then we supply K3 from IO0 with 12 volts. And the 12 volt and the ground connection is coming from the pin C on the smart meter, which is the minus pole on the connector of the Symo Hybrid inverter. And then we get another feedback from I5 from the K3 relay, which goes to I5, the feedback here. All of these can be done with one cable, a Cat5 cable, so we need actually 7 wires here. And in the Cat5 cable you have usually 4 wires which can be used here on to use this to wire this from the inverter to the switchboard. Yeah, that's actually all you need to do. Then second step is we have to activate the emergency power setup. Basically, whenever you have installed the Symo Hybrid inverter, you first set up the date and time and the country setup of the inverter. So that's the first step. But then you need additionally to adjust the EP 50 Hertz setup, the emergency power setup. Therefore, press the second button from the right hand side 5 times in a short period after another. Then you will see the code, a 5-digit code, which need to be entered, and that's a 39872. So just select these numbers with the plus minus buttons and then enter again twice, and then you come to the emergency power, to this selection of the different setups, and here select EP50 emergency power 50 Hertz. Theoretically, you could also select EP60 Hertz in a 60 Hertz installation when you have 60 Hertz in your country. And then if you have chosen this, you confirm that, and it's done. Then the setup will be reloaded. After a minute, the inverter will restart. Yeah, then the third step is the I/O mapping. For the I/O mapping, you need to first connect your laptop or your smartphone with the Wi-Fi access point of the inverter. So first you open the access point, connect with your smartphone, and then go to settings and here to I/O mapping. And I/O mapping, you have to adjust the emergency power mode. So you just click on emergency power here and then save these settings here. So that's actually all what's needed. So you need these pins 0, 4, and 5 for the emergency power mode. So that's the I/O mapping. And then the last point, under System Overview, you have to start the operating mode to automatic backup power mode. Yeah, and that's it. Then save the setting as well. Here again with here on top, click on that button, and then it's all saved, and the inverter is running. So basically here on that page you can also adjust the battery, so you can activate the battery, choose the right battery, activate the PV generator, select the right PV power, and activate probably an external producer, maybe a second existing inverter, on-grid inverter, which has to be also activated here. And last but not least, the smart meter, the Fronius smart meter on the feed-in point needs also to be selected here. That's actually all about that, all about the settings. When you've done this, the inverter should run and operate. Another thing you can do, you can reserve a remaining battery capacity. If you know that this is in this region or at this house there are many blackouts, many power cuts, then we would recommend as well to select a certain remaining battery capacity. So you can select here between 5 and 100%. You can choose here to reserve a specific remaining battery capacity in case of a blackout. But you also should know, when you do that, you cannot use this capacity for your standard operation, which is to supply the house in the night, at night, when the grid is on. So therefore, maybe don't go too high with these settings here. Maybe 20%, maybe 30% maximum. Good. Then I'd like to give you a short outlook on the new inverters, Gen 24 Plus inverters. The Symo Hybrid will also be coming in bigger power classes from 6 to 10 kilowatt in a 3-phase version, but also later on in a 3 to 6 kilowatt single-phase version. This is the Primo then. So we start in Q3 with the Gen 24 Symo inverters. So this will be the first product of this new generation which will be available, and therefore I'd like to also to recommend first to use this one. These inverters have 2 MPP trackers and also a battery input. We have 2 backup power modes available on that inverters. That means there is the full backup mode as we know it, as we have explained before, very similar to the Symo Hybrid, no big difference, basically same wiring required. But also we have a PV point and the PV point is an easier version of the backup power mode. So for all customers who don't want to have these additional wiring backup power switch over, because it's maybe too high cost for them or it's too difficult, you can offer as well the PV point. And I will explain that on the next slide, what it is and how it works. And we have also using the bigger BYD premium batteries now from 5.1 to 22 kilowatt hours. So this is the new premium version, which is compatible now with these inverters. So now, how does the backup PV point work? Basically, first you see when the grid is gone, there is the power supply from the PV generator to the PV point. So this would also work even without the battery, but of course only during daytime and only if there's enough PV power available. So that's basically could be a start for the customer to start with this. All you need here is just a socket, 230 volts, single phase, maximum 3 kilowatt power here. Yeah. When you have a battery, we can also charge the battery in this during backup power. So the battery here would also be charged with the additional PV power. And of course, at nighttime, we then can use as well with the battery the energy from the battery to the PV point. So that's more or less an easy, basic grid backup solution. Then the full backup power solution here with a battery, there is a battery needed, and of course as well the backup power switch also required. In this case, when the grid is when there's a blackout, let's say, the system's backup switch would switch over, and the system will be supplied as well from the PV generator to the battery and to the loads, as well as the battery to the loads, of course, at nighttime. Yeah, and this is the full backup power solution where we supply all household loads with this system. Good. Another additional nice feature on the Gen 24 is that we have an app available which makes it very easy the commissioning. So it's a 3 easy step commissioning, very good usability with your smartphone. You do your network, you start with your network integration, bring the system online, second to the product settings, and then bring the system to SolarWeb as well. There's an automatic Wi-Fi connection, so you don't need to open an access point. You don't need, but very easy, just with one button. But you don't need to find the right IP address from the device, so it's automatically connected. And it's all in all the easiest commissioning on the market for a hybrid system. Yeah, that's it for the moment. I would like to summarize very quick the main advantages of our Fronius backup power solutions. This is first the highest autarky, because we can also charge the battery during a blackout. We are more or less independent here. We have a 3-phase backup power, so all loads can be supplied. There is no, you don't need to change the loads in to bring them on phase 1, for example, as you have with a single phase solution. You leave the household supply as it is. We use standard components, the inverter, the battery and the smart meter, but then also the standard backup power components, the conductors, relays can be ordered from your standard distributor. So they will be having these components. We can find that easily. And yeah, the PV point is something special, but only for the Gen 24 inverters. So it makes a very cheap solution for all customers who don't want to spend a lot of more money for this backup power function, because it's maybe not necessary for their markets or very seldom necessary. And of course, you can get all information, and you can contact our Fronius support hotline under pv-support@fronius.com, where you can get additional information whenever you have any questions. Yeah, more information can be found on our webpage. The Fronius storage solution training. We've also offered webinars, YouTube videos, and documents. Therefore, go to our webpage under Solar Energy and Info Center. You will see this button Installer Support, and here you can find all operating manuals, the diagrams for the backup power mode. You can find as well some videos, commissioning videos, as well as training and webinars. So I think that's a very useful link to get all the information from Fronius about this or other questions. Good. That's it actually for the moment. I'd like to also give you the information that we will do a recording. So this webinar is recorded and will be sent out tomorrow to you once again. So if you have missed this presentation or just you didn't have time for the whole presentation, and then you can also find more information on the webinars. Tomorrow we will offer another webinar about the BYD combination with the Gen 24 inverters, for example. So if you're interested in more details about the battery solution with BYD, please join this webinar. Good. Then I would like now to answer your questions, and therefore I would like to ask Christoph, who is in the chat, to maybe show us, answer the most important questions right now. Christoph, can you hear me?
Yes.
Good. Hello.
Yes, I can hear you.
Please help us with the most important question.
Just to so just to pick out a few of them, I answered most of them right away via the chat, but just to pick a few of them, there was one question regarding the runtime within the backup mode. So what do we mean by 15%? Actually, as Hans already mentioned, we haven't built the island inverter. It's just a hybrid inverter. The components are not built for running 100% in off-grid mode. So therefore we say only 15% during the whole lifetime of the inverter should be in backup. So it's just a matter of component stress in this matter. Yeah, and another one is regarding the LG. A lot of you are asking, why isn't the LG battery displayed in the Symo Hybrid part? Actually, it is still compatible to the Symo Hybrid, but why we didn't pick it here is because it's not possible to do an off-grid solution. So the backup solution is not possible with the LG battery. We therefore need the BYD battery, and therefore it's not displayed in this webinar. Yeah, and maybe one last one. What's the maximum output power on the PV point that is possible on the Gen 24? So it's, as we heard, it's a single phase output, and 3 kilowatt is the maximum we can get out of there. But within a few seconds, it's also possible to overload it, let's say, I think up to 4 kilowatts, something like this. So it's not 100% restricted to the 3 kilowatt. Yeah. There are still some questions going in, but I will now hand over to you, Hans, and we answer the rest of them via chat.
Yes, Christoph, thank you very much. Yeah, we will answer that in writing. And I would like to switch off my microphone now, and but we stay online with you. We are still. Please feel free to send us your questions within the next 10 minutes, and we will answer that immediately now in writing. Good. Then thank you very much for your participation. I hope it was interesting for you, and I hope you can use this in your market. And I wish you a good afternoon, or don't know where you are from, maybe morning. And would be pleased to hear you once again on one of our next webinars. So feel free to participate on one of the next ones. Thank you very much, and goodbye.